Good evening, my 11th standard warriors. It's the second lecture of circular motion, and we have talked about how things are happening in the kinetics of circular motion. Tonight, we are going to see the dynamics. That's the centripetal and the centrifugal force. All of this with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. Welcome. Hi Ashpreet, hi Chitra, Tejas, Gokulnath, Roshni, Vedantu Commerce, my god, okay, welcome. Hi Samuzi, hello Ashpreet, hello Harita, welcome aboard, welcome. I always wait for this time when I get to meet all my lovely warriors, and trust me, just like you guys wait for me at 7:30, that's my usual time on this channel. I am also always eagerly waiting to come on YouTube. My day seems incomplete if I don't meet you guys out here. So thank you for all the love. Thank you for supporting this channel, and thank you for sharing, recommending, and also if you have not yet liked, also please do that, and also subscribe to our channel in case you want to stay updated, stay tuned with our regular classes. So today is the second lecture, and this is a part of Nurture series. That means this is a long-term course. We started right from units and dimensions, and now we are in circular motion. Okay, so if you want to know more about me, you can definitely follow me on my Instagram handle, and also it's a good time that we congratulate all our lovely, amazing FODU toppers who have made everyone proud. They are your seniors, and next year you guys are going to be on this chart. I'm pretty sure you guys are going to ace it. This year you have KVPY exam. Next year, okay, you are going to write the next level of KVPY exam, maybe other Olympiads, and the year after that you're going to give your JEE examination. Every year you have some or the other exam, and I'm pretty sure with continuous support, with your dedication, with your hard work, and whatever materials, whatever teachings we give you over here, you will be able to crack these examinations. Thank you guys so much. My god, Saja has filled the screen with hearts. Thank you Suchi Mama. Thank you Legendary Abhi. Hi Karthik, Dwarka. Nice to see all of you. Hi Zayad, the JEE Crackstar. Nice name, bacha. Oh, Karthik King. What's the bomb for, man? What's the bomb for? Okay, please don't blast us. Let us stay alive. Hi GTMFF. Welcome aboard. I'm very good, and it's also a good time that we see who and all have done the homework last time, so you know where to check. So this is our channel, and you can go to playlists, and this is going to give you all the sections, and over here you have JEE Physics. Okay, so you can see all the playlists over here. This is Nurture. All the videos of 11th standard are over here. All the videos of 12th standard are in Pathfinder. You can see we started from the bridge course, units and dimensions, and right now we are in circular motion. Okay, now the circular motion playlist most likely has not yet been made. Okay, it will be made soon, don't worry. But let's go to the circular motion video right over here. That was me last time. And very good Ishpreet Mangat, very good Saja, excellent Paulami, Rajiv, Molesh. You guys were really quick, huh? Very good. Harita, Devesh, I think he had asked it out, I cleared it. Pushpanjali, Anil, thank you for all the love, bacha. Kamlesh, Suchi, oops, I didn't like it yet. Okay, let me just like it. Okay, Gokulnath, Priyaji. So you can take up the long-term course. I'll be very eagerly waiting for you. And yes, you can also attend these classes for NEET as well. Thank you guys for posting the answers. And that was really quick. So today also I'll be giving you guys some homework. Post it up in the comment section below. And if you want to join my regular batches, my micro courses, and other teachers courses, all teachers are amazing. There is a batch starting on Monday, and you have 3 versions of it, and the lowest course price is 3,600 rupees per month, which gives you everything. But if you want doubt solving, then you go for the classic, and if you go for plus, you also get the mentorship. There is a link, guys, in the description box. You get 10% off on all our courses for JEE NEET, no matter, even if you are preparing for CBSE. So let's start, and yes, do not forget to join our Telegram channel as well. Here's the first question coming up on your screen. Oh, no problem, Suchi. It's okay. You at least posted. Fida, very good, bacha. Nice to see all of you. And by the way, let me also break something for you. I am going to have many more classes with you guys because the 2021 batch has passed out. So we have more time. So more time for 11th and 12th standard classes. So guys, get ready for the first question on your screen. The car is going along a curved path. Is the velocity changing? Yes or no? A or B? Come on, my warriors. Sir, is solving Tattva and PYQ enough for NEET? Saja, it will be decently enough. But if you want to like ace it. Okay? So with those two books, you will be able to get 150 around. If you want to get 180, then you need to probably look at some extra material also. Okay, so to reach full marks, that's what you need to do. But Tattva and PYQ will be just enough to get you around 150 easily. Okay, the correct answer is yes. Yep. Why is the velocity changing? If the car is going along the curved path, the direction is changing. And what is velocity? Velocity is a vector. So it has both magnitude and direction. That means, hence, if the car turns, obviously the direction changes, and hence the vector changes, and hence the velocity as a vector is definitely changing. Next question coming up on your screen. A car is going along a curved path. Is it accelerating? Come on, let's see if you can get this. Yep, very good Harita, yeah, very good Ashish, Anil, excelente, very good. What about a car which is going in a curved path? Is it accelerating? Yes or no? Some of you are saying yes, some of you are saying no. Clearly there is a confusion. Yes, let's see what's the correct answer. So, what is acceleration? Acceleration is rate of change of velocity. Is velocity changing? Yes. So then, is it accelerating? Obviously yes. Hence the correct answer for this question is also yes. Yeah, you can see that. It is definitely accelerating because remember, acceleration is nothing but the change in velocity upon the time taken. That's what acceleration is. So if the car was going like this, after some time it has gone here, so definitely this is the change delta V in some time. So definitely it is accelerating. Okay, many of you got this wrong, but now I hope you understood this. Next question. A car is going along a curved path. Is there any force acting on it? Okay, let's see. The velocity keeps changing. Yes, it is accelerating. Correct, Suchi Mama. Now, try to answer this. There is a car. Okay, let's assume that the speed is constant. Let's say I add constant speed, but it's going along a curved path like it is shown over there. What do you think? Is there any force acting on it? Net force? What do you think? Yep, there is net force. So a lot of you are saying yes. Let's see whether that answer is correct. And yep, that answer is correct. And now you will guess why there should be a force. See guys, if the car was going here right now initially, after some time, let's say it goes here, finally, there is an acceleration towards the center. And what is that acceleration called? That is called as centripetal acceleration. Why is there a centripetal acceleration? Because if the car is turning, it's going in an imaginary circle. You can see that? It's going in an imaginary circle. This is the center of that imaginary circle. Hence, if it is turning, obviously there is an acceleration towards the center, and that is only responsible. What is it responsible for? This acceleration? Only for direction change. That's for direction change, and I had given you the value of that, which was v square by r, or you can also use omega square r. One and the same thing. Both are the same values. So this is the centripetal acceleration. If there is acceleration, there must be force. That is Newton's law. So by Newton's law, F is equal to ma. So if there is acceleration, there must be force. Hence, there must be some force towards the center. This force, which is acting towards the center, this is called as the centripetal acceleration. Correct though? Yes, that's an imaginary center, imaginary circle. So only when there is force, there will be acceleration. Just think about it. If I tell you there is a body and it is accelerating, it is increasing its speed, or it is changing the direction. Just imagine, I tell you there is a pen and magically it is turning. Like, sir, what the hell? How can it turn magically? There must be somebody to change the direction. That somebody is giving some force. only then there is acceleration. Without force, there cannot be any acceleration. Keep that in mind. So that force is basically called as centripetal, over here. Yeah. That force is called as centripetal force. Now many people have some misconceptions about these force. Let me be very clear about this. See, that force which comes into play when a body moves in a circular path, okay, that means changing direction, that force is called centripetal force. It is directed towards the center of that circle along which the body is moving, and that force will be m into acceleration. Acceleration is v square by r, which is also omega square r. Now this force is not like your gravitational force or tension force or normal force or friction force. It is not a new force. Very, very important. It is not a new type of force, but rather it is basically a name given to the force or forces. What do I mean by this? Okay, force or forces. Just imagine this. There is a particle which is going in a circular path. Maybe there is some gravity, mg, maybe there is some tension, maybe, I don't know, there could be some friction, maybe the friction is here, I don't know. All these forces together, their components towards the center is the centripetal force. For example, in this case, let's just keep two forces so that you understand what I am talking about. What are the forces acting towards the center? Okay, there is one tension over here, you can see that. And let's say if this angle is theta, can you see mg will have two components, one this way and one that way. This component is towards the center, so that is mg cos theta. Both of them together is called as the centripetal force. Both of them together is called as the centripetal force. And what does force do? The force always gives mass into acceleration. So that's it. So just write this is equal to mass into centripetal acceleration, which is m into v square by r. So understand, centripetal force is not like a new force. You should not show on the FBD centripetal force. That is wrong. In fact, when you draw the forces, some of those forces will be the centripetal force. It is the name given to some force or forces. Is that clear? Is gravity a centripetal force? It can be. In fact, any force can be a centripetal force. A combination of forces can also be a centripetal force. It's just that it's all those forces which act towards the center of the circle. Those components are called as the centripetal force. I hope that is clear. Let me know if it is clear. Let me know in the chat box by putting up a yo. Now you might be wondering, sir, okay, I understood this much. What if let's say there is friction this way? Will friction be a centripetal force? Yes, it is still a centripetal force, but that time be careful. Tension plus mg cos theta, these two are acting towards the center, but friction is acting away from the center. So minus F. This together is now your centripetal force. These forces together is your centripetal force, and we know centripetal force is mass into acceleration. So this sum will be equal to mass into v square by r. I hope now it makes sense. Yep. I hope this is clear. Very, very important. So centripetal force is not mv square by r. Centripetal force comes out to be on the RHS. It is equated to mass into acceleration. Acceleration is v square by r. So do not by heart centripetal force is mv square by r. No, that's not the correct way to look at it. Centripetal force will be sum of the forces. Addition, subtraction, it could be anything depending on the directions. Let me give you some examples of this. Look at this. Okay, the motion of the earth around the sun or motion of any planet around some other celestial body. Why would any body turn? Because most of the bodies, by Newton's first law, if you throw it, it should continue moving in a straight line. but there is a reason why it is turning. What is that reason? Gravitational force. So who is the centripetal force here? Gravity is the centripetal force. Gravity is the centripetal force. Yeah. So is the centripetal force acting between sun and planets? No, Ashish. There is no centripetal force. There is gravity which is acting. Gravity is called as the centripetal force in this situation. In some other situation, some other force might be doing the job. It's like a title. It's like a job title. That role can be played by different characters. In this case, the character is gravitational force. Think of it that way. Look at the other example. The motion of an electron around the nucleus. We know positive and negative charges attract each other by electrostatic force. That is also going in a circular path. Why is it going in a circular path? There must be a force. Which is that force? Electrostatic force. So here, electrostatic force is the centripetal force. I hope that makes sense. Okay, so the job of the centripetal force is being played, that role, like you would have done drama in your school, or you would have seen some natak drama in your, maybe in your society. So there might be a role of some character, maybe some villain. The role of the villain can be played by so many different people. The role of a heroine can be played by so many different people. So every time that role is played by different forces. That role is called as centripetal force. Okay, look at the another example over here. Okay, this guy is going in a curved path. Why is he able to change the direction? Think about it. Why is he able to change the direction of his motion? Think, is it gravity? No. Is it normal? No. Is it friction? Yes. Why is it friction? Because friction is the only force which can act along the road, along the horizontal surface. Imagine the surface was smooth, completely slippery. There is oil spilled over it. Will he be able to turn? Think. You are moving on ice or slippery surface, completely smooth. Will you be able to turn? No. That means friction is responsible. Friction is not a bad guy. A lot of people, unnecessarily call him a villain. He is a good villain. Okay, sometimes he is good also. Don't worry. Yes, he will slip. Definitely. So friction is the centripetal force. I understand that. All right, moving on to another example over here. Okay, you might have taken SE show off. People do that. They tie something, a string, and they do like this, like a hero. You might have seen in some movies. Yeah, or sometimes in some movies they do this, and the hero throws it on the villain, and the villain gets captured by some weird non-physics phenomena. Okay, let's not talk about that. But anyways, if you do this, why is the stone able to go in a circular path? The reason is again tension. Tension is the centripetal force. Without tension, if you cut the string, zoop, the stone will fly away. The stone will be like Newton's first law, Zindabad. And it will be like, I will move, I'll try to move in a straight line. I will not go, in a circular path. So the stone will just fly off. That's what will happen. Correct. So tension is the centripetal force. Correct. Let's move on. Okay, to the next question coming up on your screen. And here it is. There is a string and it will break under a load of 5 kg. That's what is mentioned in the given question. To one end of such a string, which is 2 meters long, there is a mass of 1 kg which is attached. What is the maximum rounds per minute you can rotate the string with? Okay, let's try to do this question, guys. What do we have over here? There is a center, and from the center there is a string whose length is 2 meters, and I have this mass. How much is this mass? This is 1 kg, and I'm rotating it. Okay, I do not know with what speed, but let's just assume this speed is omega. Omega is the angular velocity. Now, obviously there will be some tension. Now, if you rotate it fast, the string will stretch more, tension will be more, it might break. So when you are trying to move it with maximum speed, the maximum speed will have the maximum tension. Okay, we'll put that tension right now as T, but there will be a tension on that mass for sure. What will the tension do? Tension will create acceleration. Where will the acceleration be? Acceleration will be over here. This completes our free body diagram. What is this, guys? This is our free body diagram. I've told you how to draw free body diagram in Newton's laws. Okay, that's it. Do not be stupid to draw centripetal force now. Don't show centripetal force. No, there is nothing like centripetal force. This tension is the centripetal force. Just use your Newton's laws of motion, second law. That's all you need to do. Newton's second law of motion. Tension will be mass into acceleration. Well, do I know the value of tension? Yes, because the maximum tension is the tension which can support 5 kg. 5 into G. That's the tension. I hope this makes sense. 5 into G, because 5 kg is the mass. 5 into G will give me the force. Mass, which is 1. Okay. Acceleration is omega square into radius. The radius is 2. Interesting. Therefore, I will get omega square will be 5 into G divided by 2. That's what I got omega as. But I don't want omega. I think I want in RPM. Okay, let's do this. RPM, that means first let me find out omega. Omega is root of 5 by 2 into G. Now I know what is the value of omega. Last lecture I have told you about this. Omega is nothing but 2 pi into frequency. Try and recollect this. Omega was 2 pi by t. 1 by t is nothing but f. So omega is 2 pi f. I had given this to you last lecture. So that's it. Use that over here. Now I'll tell you what, there's a very good approximation you can use. I don't know whether you know this. Root of G is approximately equal to pi. I don't know if you know this. Yeah, root of G is approximately equal to pi, because pi is 3.14. If you square 3.14, obviously you will get some value close to 9.8 only. That means this pi and this G, root of G, will get cancelled. Interesting. So therefore, F will be equal to, okay, so that 2 goes over there. So it will become 1 by 2 root of 5 by 2. But this is hertz. I don't want hertz. I want RPM. So what do I need to do? Multiply. This is per second. So in 1 minute, how many rounds will be there? Into 60. So that will be equal to 60 into half into root of 5 by 2. I hope you understood why I did this, because I want RPM, rounds per minute. This was rounds per second. So in 1 minute there will be 60 times more rounds. So that's why I multiplied by 60. So this will be 30, guys. So can I write 30 as something? Because this will be 30. I think I can write 30 as 15 into 2 and into root of 5 by 2. So this will become 15 and root 2 will remain on the top into 5. Acha. So this will become 15 root 10. Root 10 will be slightly more than 3. Root 10 will be 3.1 or something like that. Correct? Now 15 3s are 45. So something which is slightly more than 45. Which is that number? 47.73. Done, done. Happy Navratri, Ankit. Correcto, Tanishq Mishra. Excellent. Got it? Yep. The answer is B. So that's how you need to do the calculations. I didn't even sit and calculate the value. You just need to think. Look at the options. 15 3s are 45. Root 10 is slightly more than 3. So 15 into a number slightly more than 3 will be 47.73. That's the answer. Correcto. Moving on to the next question. Okay. Suchi, can you do one thing? Can you watch the replay again? I hope you will understand it. It's very simple. It's just, even if you try it out on your own, I'm pretty sure you will get it, Suchi Mama. Okay. Hi, Vasanti Bacha. Yep, Hanil, done. Now the next question involves a car which is going in a curved track. And we will see what is the maximum speed with which you can turn. You might have seen some funny videos where a car or a bike or a truck is trying to turn. It's trying to negotiate a turn, and because the speed is too large, it skids and flies off. So we will try to figure out what is the maximum speed with which you can turn around a track. So let's do this question. So there is a car and it is going along a circular track, okay, of radius r and coefficient of friction mu. Find the maximum speed of the car without slipping. Okay. So this is our car. I hope you can see that. And let's try to see what kind of forces are acting on it. Obviously, if the car is going like this, can you see that? If the car has its velocity, okay, the car has its velocity this way, it's going like that. The imaginary center will be here. This is a big circle. So there must be some acceleration towards the center. So I will show that acceleration towards the center here. Okay, I hope you can see this. This is the acceleration towards the center of that imaginary circle. What are the different forces acting on the car? Well, number one, there will be weight, right? Gravity will pull that car down. I'm trying to draw this in 3 dimensions. There will be mg downwards inside, okay? There will be also a normal force like that. There will be also a normal force like that. There will be one more force. I think there will be also friction somewhere. Where will that friction be? Think about it. Think about it. Where will the friction be? The friction will be towards the acceleration. Why? Because normal and gravity are perpendicular to the acceleration. I hope you can see that the normal and the gravity both are perpendicular. They cannot provide acceleration. So who will provide acceleration? Obviously friction. So hence, no, friction will not act backwards. A lot of people make this mistake. Sir, friction will act here. No. Friction is not acting backwards because it is not accelerating along the tangent. It's moving with a constant speed. So even if there is friction on the tires, it's cancelling out each other. So guys, understand that velocity is constant. That means there cannot be friction along the tangent, or else there will be a net force along the tangent and the car speed will increase, which is not happening in this case. So the only possibility right now is that there is a friction acting towards the center. I hope this is clear. I hope this is clear. Now what do we do next? Okay, Uday, by the way, I have already done strategy sessions just few weeks back. I've done 2 or more strategy sessions. You can check it out, bacha. Okay, so please watch it. Now here is the next thing. The only law I should use is Newton's second law. So let's use Newton's laws of motion, second law, of course. So friction will be mass into acceleration, the centripetal acceleration. Now what will be the centripetal acceleration? Centripetal acceleration will be v square by r. Why am I using this formula? Because v is given. Now what is this expression telling me? This expression is telling me if you increase the speed, friction will also increase. You increase the speed more, friction will increase. But guys, can friction increase indefinitely? No, right? There is a limit till which friction can increase. There is a limit. And what is that friction called? Limiting friction. So when you move with maximum speed, this F will become Fs max. And this will become mv max square divided by r. That's what will happen. Now Fs max will be mu into n. This will be equal to mv max square divided by r. Next, what is normal, guys? The normal, you can see from here, normal is being just balanced by mg. So mu mg will be m into v max square divided by r. Goes, r shifts on the other side. So mu into r is equal to v max square. Therefore, v max is equal to, oops, that g was also there. Yeah, that g was also there. So root mu r into g. So that's our final answer. Done. So guys, what has happened over here? Here we saw that as you increase the speed, friction will also keep increasing. But friction cannot increase beyond a limit because there is limiting friction, mu n. So that's when the speed will be maximum. If somebody tries to go with a speed more than this speed, root mu rg, he is for sure going to slip, he is going to drift, and he is going to hit the outer side of the road. Understood? Clear? Chalo. Let's move on to the next question coming up on your screen. Root mu rg, r is the radius, g is the gravity, mu is coefficient of friction. Okay, look at this question. This is a beautiful question. Yep, we have come to motion on a banked road after some time. Dakshin, hold on, everything is going to be taught today. Don't worry about it. Here is the next thing. You might have tried this for sure at home, where you take a string. Okay, right now I have a charger, I don't want to do it too much. Okay, you take something and you rotate it like this. You rotate it like this. And that is nothing but a conical pendulum, because it traces the surface of a cone. If you make it oscillate like this, that is a simple pendulum. It goes back and forth. That is simple pendulum. But if you make it go like this in a circle, that is nothing but a conical pendulum. If you try to rotate it faster, you will see that the angle will increase. If you try to rotate it slowly, then the angle will decrease. So I am interested what is the tension and what is the angle made by such a conical pendulum, if everything is given to me. Let's try this out and see what happens. Okay, so a conical pendulum with a bob, that's a point mass m, it is attached to a string of length L meters. It moves in a horizontal circle with an angular speed omega. What is the tension and what is the angle between it? Okay, so let's try to do this question. First of all, let's try to visualize what are the different forces and where is the circle, where is the center. Well, the circle is here, the center is there. Therefore, for sure, there must be some kind of acceleration towards the center of the circle. Okay, next step, obviously the velocity will be along the tangent. Try to visualize this in 3 dimensions, guys. Okay, so the velocity will be like this. Okay, and if you want, I can also show omega like this. This is omega. It will rotate like this. Okay, so let me just put this centripetal acceleration as it is over here. Velocity was like that, or angular velocity is like this. I'm not showing V because everything has to be found in terms of omega. Next up, the forces acting on them. Obviously, there will be one tension this way. There will be one tension this way. You will also see gravity acting down, and the gravity will be perpendicular to the acceleration, and the tension will make an angle theta with the vertical, because if this is theta, this will be theta. Apart from this, there is no other force. Keep this in mind. Okay, one last thing, I need the radius of the circle. You can see this one over here. Okay, this is nothing but the radius of the circle. You can see that this radius, okay, if I may write it over here, this radius is opposite to theta. This is the hypotenuse of that right angle triangle. So can I say R will be L sine theta? Okay, so that's the radius of the circle. Now let's use Newton's laws of motion, nothing else. That's all you need. Which force is providing the acceleration? Which component or which force is providing the centripetal acceleration? Just think about it. Is it, no, there is no normal. Follow me, there will be no normal because it is not resting on any surface. It is hanging. Remember, I just showed it to you. So there is no normal at all. Yep. Tension? Yes, but not the complete tension, only the component of tension. Because in the direction of acceleration, the tension's sine theta component, because cos theta component will be up, sine theta will be that way. So I feel I should write tension's sine theta will be mass into centripetal acceleration. Okay, now what is the centripetal acceleration? It is nothing but omega square r. But what is r? I just wrote it over there. It is nothing but L sine theta. So this is nothing but T sine theta. The best thing is, sine theta and sine theta will cancel. So I'm just left with tension, which is what I wanted, which is m omega square L. So I have found out the first answer. Tension is m omega square L. If I rotate it fast, omega will become more, tension will also grow. That's the first answer. Great. Now, the next thing is basically all about, figuring out what is the next component that you will use. The next component where I think I should use it in the y direction. Okay, in the y direction, tensions cos theta will balance mg because there is no acceleration in the vertical direction. The acceleration in the y direction is 0. Therefore, the tensions cos theta will be balanced by mg. But wait a minute, I know the value of tension. That was nothing but m omega square L. I'm just putting it over here into cos theta is equal to mg. Therefore, you will get cos theta is equal to cancels g divided by omega square L. Therefore, theta is cos inverse of g by omega square L. That's the final answer. Done, done. That's it, guys. So, what and all equations were required in these questions? There were only two things. One is the force in the x-axis. T sine theta was mass into acceleration. Second thing, force in the y-axis will balance out each other because there is no motion in the y direction. So that's why just using two equations you will get the answer, and R is L sine theta is simple trigonometry. I hope this is clear. Yep. So can I, Saja, you should practice especially exercise 1, exercise 2 from Tattva module, and after that the PYQs at least 50-40% from that particular chapter. Okay, so that's a general rule of thumb that you can follow. Okay, interesting. So m omega square L and cos inverse of g by omega square L. Now moving on to the next part, but before that, let me also tell you, if you guys have any doubts, then please download the Vedantu app. There is a feature called Ask Me Anything. You can take a screenshot, you can chat with our doubt experts. They sit from morning till night, almost all the days, and you can get all your doubts cleared, including, you know, your probably, let's say, you don't know whether this method is correct, you want to just get a hint or something, you can ask anything like that. So unlimited doubts, free of cost if you are a pro student. Now moving to the next one. Oops, should I have lassi? No, maybe I'll have water for sure. How many of you remember this? How many of you were there for this class? Let me know. Meanwhile, I'll drink water. Suchi, 20-30 is very less per chapter. You should practice 100 plus. Pseudo force, yep. Okay. So some of you remember this, some of you don't. So Bacha have already done strategy sessions for physics. If you can check my previous videos, you will find strategy sessions, what to do, what not to do. I have done many videos. Please check it out. I think you have missed out on that. Check it out. I have done many videos. Yes, some of you might remember it. I had given you that Laddu happy question by giving me pseudo force. Yes, correct. And now, what is a non-inertial frame? A non-inertial frame is nothing but a frame of reference which itself accelerates, like a falling lift or an accelerating car or something. For some reason there is a force because of which it is accelerating, that becomes a non-inertial frame. Now what is the problem with a non-inertial frame? The problem is, you cannot apply Newton's laws. So in case of non-inertial frame, you cannot apply Newton's laws. So that's why you give a laddu, and that laddu is called pseudo force, a fake force which does not exist. So apart from your regular normal friction, tension, spring, whatever forces you show, you add one more force. What is that force called? Pseudo force. What is the direction? The direction is exactly opposite to wherever the frame is accelerating. Let's say I'm a car, frame of reference. If I'm accelerating this way, pseudo force will be that way. If I'm accelerating this way, pseudo force will be backwards. Pseudo force always acts opposite to the frame's acceleration, and the magnitude is mass of the body into acceleration of the frame. So the total force will become all the other forces plus the pseudo force. That will give you mass into acceleration. That's all it is. Yeah. Now the same logic can also be applied in case of a circular motion. Okay. Just imagine you are sitting in a car. Just imagine you are sitting in a car and the car is turning. If the car is maintaining its speed but turning, we just described that is acceleration. We know that the car is accelerating towards the center. So that is also a non-inertial frame. Correcto? Think about it, my warriors. If you are in a car or a bus or a train and the train or car or bus is turning, that is also accelerating. That means you are in a non-inertial frame. That means you cannot apply Newton's laws. If you are standing outside and watching the phenomena, you will see the car or whatever objects going in a circle. But if you are inside that object which is going in a circular path, you are in a non-inertial frame. And this is something what you will see. Let me just show that simulation. Look at this. If you keep something and if you turn, you will see everything moves outside. You are pushed outwards. That outward force is a fictitious force. You feel that you are being pushed outwards. Actually, you are not being pushed outwards. It's just that it's the car's fault. It is the bus's fault that it is turning. Otherwise, you would have gone straight. If you would have gone straight, these oranges, these balls would have just stayed there, right? It would not do anything. It's your fault that you turned, because of which it got pushed outside. And you will find many such examples like this. Let's say you are on a merry-go-round. If you are on a merry-go-round, you feel that as if somebody is throwing you. In that rotating, non-inertial frame, you feel that outward push. That outward push, that fake force, that pseudo force is called as centrifugal force. Yeah. So what is a centrifugal force? Centrifugal force is nothing but a pseudo force which acts in a rotating frame, in a rotating non-inertial frame. The moment you are in a rotating frame, remember you have to use pseudo force. So now we have two ways of solving a problem. One way, you sit on the ground and look at the problem, or you be in that circular motion and then look at the problem. Both ways you will get the answer. Don't believe me? Let me show this to you. Just imagine that same question. Okay, we have a string, we have a mass over here. Okay, now let's say you are on the ground frame. If you are on the ground frame, okay, what will be the difference? And when you are in this frame, what will be the difference? Let's see. First of all, if you are in the ground frame, that mass will have some acceleration because you will see it going in a circular path, and there will be a tension over here. So you will say tension is mass into acceleration, and you will therefore say tension is equal to mass into v square by r. That's what you're going to say, or you will also say either omega square r. One and the same thing. Now let's say you are in this rotating frame. This is a non-inertial rotating frame. In this non-inertial frame, you will experience a centrifugal force. What is the value of this centrifugal force? The centrifugal force is always m omega square r. Keep this in mind. What is omega? Omega is the angular speed of that frame which is rotating. So this is that frame of reference which is rotating. So if you are rotating with omega, that omega should be put over here. What is m? M is the object which you are observing, the object which is being seen or observed or whose FBD you are drawing. And r is the distance from the center, distance from the axis or the center. So over here, when you draw the free body diagram of this mass, there will be two forces in this non-inertial frame. There will be tension and there will be that pseudo force or centrifugal force. And this object, see, if you are rotating with it, for you guys, that object is at rest. The world is rotating around you. So this object will be at rest. Yes, this will be at rest. And then you will say tension minus the pseudo force is equal to mass into acceleration. This is at rest. Very, very important. Therefore, you will say tension is equal to Fp, which is nothing but m omega square r. It's one and the same thing. You should get the same answer no matter how you solve it. If you are sitting on that rotating frame, you will see that the mass is at rest. So the net force will be 0. Tension balanced by pseudo force. If you are sitting outside, you will see the mass going in a circular path and you will say tension is providing the centripetal acceleration. That's it. Now, is centripetal and centrifugal force different? Yes, it is different. Is centripetal force and centrifugal force action reaction? Let me know in the chat box. What do you guys say? Is centripetal and centrifugal action and reaction? Think about it. Is it action and reaction? No, it is not action and reaction. Think about it. Aslam Stravanan, there is already a KVPY batch running for physics, chemistry, maths, you can join the KVPY batch, and definitely that will help you for your KVPY preparation. No, Abhinav, it is not action and reaction. Keep that in mind. Okay, so they are not action and reaction because first of all, they do not act in the same frame. They do not act together, and they are also acting on the same body. It follows none of the rules or the qualifications of a Newton's third law. Remember, you use centripetal force in ground frame. You use centrifugal force in rotating frame. So either you use this or that. Number one. Number two, this force, tension, which is the centripetal, or the pseudo force, which is centrifugal, both are acting on the same body. But we know Newton's third law acts on different bodies, and they do not cancel each other. But here you can see tension and pseudo force are cancelling each other. So guys, it is not action reaction. A lot of people, I've seen so many people telling, oh, this is action, this is reaction. They are equal and opposite. Yeah, that is not correct. That is not action and reaction. They are used in two different situations. Either this or this. When it is or, when either you can use this or that, and you cannot use them together. That means, understand that, they will not cancel out each other that way, and it's not action and reaction. Okay, very, very important. You cannot show both of them together. Okay, so let's try and solve a question using centrifugal forces. Okay, let's do this. Come on, guys. Okay, so what you have over here is there is a person, and he is basically 50 kgs and is standing on a merry-go-round which has a radius of 50 centimeters. What is the maximum angular speed so that the person does not fall off? Okay, let's try to solve this question using rotating frame. So my frame of reference is this one, and I am myself rotating. So this is obviously non-inertial rotating frame. This is non-inertial rotating frame. Next up, let's draw the forces acting on him. But before that, if you're on the merry-go-round and you are looking at the person and he's not slipping, what do you guys say? Is he at rest or no? Come on, let me know in the chat box. Hi Sai Sashi, welcome aboard. Yep. What do you guys say? Is the person at rest? Okay, you are on that rotating frame. What do you think? Is the person at rest? Yes, because no matter where you rotate, you'll always see him to be at rest. You will see the rest of the world rotating around you. Okay, for that frame of reference. So he is definitely at rest. Now what are the forces? One will be the weight. What will be the other force? He's standing on some platform, so there will be a normal reaction. Next, there will be a pseudo force. How? Outward. Centrifugal force always acts outwards, I just told you. So centrifugal force FP like this. But he is at rest. Normal mg cancels. Pseudo force will be cancelled by somebody, right? So who will cancel that? Obviously, there will be a friction over here. That's it. Now, since he is at rest in the x direction, can I say the frictional force minus the pseudo force is equal to 0? Now, what will be the frictional force? It will be mu into m. And pseudo force will be m omega square r. Okay, I've just shifted it over here. So what is n? N is nothing but mg. So this will be m omega square r. So therefore, mm cancels and I'll get omega square is equal to mu g divided by r. Very nice. So therefore, omega square will be mu. Mu value is 0.5. G value is 10. Okay. Radius is 50 centimeters. That means it is again 0.5. Acha, 0.5 goes, it will become 10. So therefore, omega will be root of 10. Root of 10, root of g, almost the same thing. So can I say omega is pi radians per second? Pi radians per second. That means it is completing 180 degrees in 1 second. 180, half a revolution per second. So this is half revolution per second. That's what is happening in this case. If you try to rotate the merry-go-round more than half a revolution per second, that person will slip and will fly off. That's what will happen. Welcome Narbavi, welcome aboard. I hope you guys are enjoying. Let's take a merry-go-round. Let's take a ride on the merry-go-round. Oh guys, I have some special surprise after 1 month. Okay, so wait for a month. I am going to post an amazing video. Just hope it works. Okay, you will be wondering, sir, why 1 month? Just wait for it. Something related to circular motion. It's going to blow your mind, and let's see what happens. Okay, I will not talk too much about it right now. Okay, the answer is pi radians per second. That's correct. Yep. Let's talk about giant wheel. How many of you are scared of giant wheels? How many of you are scared of merry-go-rounds? Do let me know. Sir, I'm in class 9. I study for 10 hours. Can I clear JEE 2025? Srivatsan, if you study like this at 9th standard, you will clear JEE 2022 only. Okay, so definitely you will. Okay, thank you, Kalyani. Yep, some of you are scared. Harsha is scared. Okay, somebody has never sat. Okay, you should experience it. It is fun. And guys, understand, you know, I might teach over here, I might give you all these equations, but you should always feel physics. I always tell my students, you should put yourself in that situation. I wish you are in front of me and I could have showed you or probably taken you out for a trip and we could have a nice outing in a park, and I made you sit in that merry-go-round. I would be considered as a very evil teacher where a teacher takes all his students and he just pushes them in all the rides and then makes them feel physics the hard way. It would be fun. Won't it be? Yeah, it would. It would be amazing, right? Yeah, and I'll be just chilling outside. I'll be having my nice popcorn or maybe candy, and you guys will be screaming your lungs out, and you'll be like, "Sir, bus ho gaya abhi, aur feel physics nahi karna hai." Okay, that would be crazy. Yeah. Anyways, so what happens in a giant wheel is that when you're at the topmost position, you feel little bit light, and when you are at the bottommost position, especially if the giant wheel is fast, you will feel little bit heavy. What is the reason behind that? And that's what we will find out. Okay, so over here, the question is, there is a 60 kg person. Okay, my weight is slightly more than 60, but let's take 60. Okay, and he's on a giant wheel of radius 10 meters. That's fine. And what would be the normal force at the topmost point and at the lowermost point? Let's try to do this question. Okay. So first of all, when you are at the topmost point, okay, at this particular position, let's see what and all is happening. So this is at the topmost position. This is our Pandu. So what is this Pandu's weight? 60 kg. Okay, he's standing on that platform, right? That giant wheel is going like this. He's standing on a platform. The Pandu is standing here. The pen is the Pandu. Okay. Now this Pandu, what and all forces are there? Let's try to draw that. One force will be obviously his own weight, okay, which will be 60 G. Then one will be normal force, and there is one more force. Remember, he is going in a circular path. So if I am in the Pandu's frame of reference, where am I? I am in the Pandu's frame of reference. So we are in the Pandu's frame of reference. Obviously, that is a non-inertial rotating frame. And in a non-inertial rotating frame, what do you experience? Centrifugal force. Centrifugal force. And where is the centrifugal force? It is always outward. Okay, it is always outward. So we'll experience centrifugal force. So outward is in this direction. This is FP. So let's see what and all equations we can write. And by the way, the Pandu is at rest, obviously, with respect to the cabin. So in the cabin, Pandu is at rest in that frame of reference. So normal and that pseudo force will balance 60 G. Therefore, normal will be 60 into G. G is 10 minus pseudo force, which is mass. Okay, mass is 60 into omega square. Omega is 0.1 square into radius. Radius is 10. Okay. 60 into 10, 60 into 10 is there both places. So 600 into 1 minus 0.01, I suppose. Okay, clear? So this will become 600 into 0.99, I suppose. Correct? So 99 into 6, how much will it be? Yeah, 600 minus 6, that's 594. So 2 decimals shifted. So this will be 594 newtons, which is same as 59.4 kg force. That's what the first answer is. 594 Newton or 59.4 kg force. Do you see a small reduction in weight? Do you see a small reduction in weight? Yes, Pandu's favorite character, correcto. Yep. Now, hurry, IPL hota rahega. Shreyas sir's lecture will not come again. So that's why Shreyas sir's lecture is more important than IPL. Okay? And you will watch IPL, what will you get? You will not get anything. They will get money. They will get crores of rupees. If you watch my lecture, you will get crores of rupees after 5-6 years. Because you will be passing out from a good college. So you decide. Do you want the players to earn crores of rupees, or do you want to earn yourself crores of rupees after a few years passing out from a good college? So that's right. Okay. Well, that's what it is. It's slightly lighter. Now, the next thing. If you are at the bottommost point, then what will be the changes? If you are at this particular location, the only change will be, let's see, this is our Pandu. Well, there will be one normal force, there will be mg force, but this time, since you are going like this, outward is this way, down. Look at this, for this guy, outward is down. So pseudo force will be here. This is where FP will be. So in this situation, if I show the Pandu at rest, the only change will be upward force normal will be balanced by the two downward forces mg and the pseudo force. Therefore, N will be equal to mass is 60 into 10 plus pseudo is m omega square r. M omega is 0.1 square into r. Again, 600 is constant. Okay, 600 is constant. 1 plus 0.1 square, so 0.01. So what will this give you? Well, it reduced by 6 newtons there, right? It will increase by 6 newtons over here. So that's it. You will get 606 newtons, which is 60.6 kg. So, you know, you can fool a person. Try this out. Next time you go in a giant wheel, a big giant wheel, you take a weighing machine. You don't believe me? Please take it. You might look like a complete idiot, but that's okay. Take a weighing machine and stand over it. Others will be like wondering what the hell is wrong with this guy. But try it out. You will see at the topmost position you will feel lighter. If on the ground, if you weighed 40 kilos, maybe at the topmost position you might weigh 39 or something like that. And at the bottommost you will weigh slightly more than 40. That's what will happen. So in this case it was 60.6 and this was 59.4. Yeah. Very good. Everyone will laugh, I know. Oh, my Pandu is looking smart. Smarter than me? Or not so smart as me? I don't know. It's a competition, tough fight. Okay, chalo, let's go to the next question. Okay, so 606 Newton, 594 Newton. Now the next amazing, awesome question is coming up on your screen. Yep. All right. Wow, you got admission in SSN Chennai. Very good, Badri. Keep your hopes high because JEE Mains admission and counseling has not yet started. I wish you all the best, bacha. Okay, now this question is all about banking of roads. So you might have seen the roads, the tracks are curved for a reason, and we are going to explain that reason, and we are going to see what advantage does it have over a road which is not turned when you are going at an angle. So this turning of a road, where the angle at which the road is, you know, that is called as the banking angle, and that phenomena is called as banking of a road. So a banked road has more advantage over a flat road, okay, and it helps in increasing the top speed of that vehicle. So this is our vehicle and it is going in a curved path, and looking at it from behind, and the angle of that road with the horizontal is theta. And the question is, what is the maximum speed with which the car can travel on a banked road making angle theta with the horizontal having coefficient of friction mu in a circle of radius r? Let's do this question. Come on, my warriors. First of all, okay, the circle is here like this. Try to visualize it. Okay, so the acceleration will be this way Now please tell me, do you want to solve it by the method where you are sitting on the ground and the car is going in a circular path, or you want to move with the car and then do it by centrifugal force? How do you want to do it? Thank you, Sarat Bacha. Oh, okay. No, it's okay, Bacha. Even if you call Pandu as smart, I wouldn't mind. Pandu is my friend. Chill. It's okay. Like river bank. No. It's not that bank. This is different. In English, the same word might have different meanings. So this is not that bank. Banked over here means lifting of one side more than the other side. So that is called as banking. Oh, let's move with the car. Okay, fine. So understand the center of the circle will be here somewhere. So let's rotate with the car. So that means I'm in a non-inertial frame. So I'm in a non-inertial frame. Okay, like this. So there will be obviously some pseudo force, and pseudo force will always act outwards. So away from the center. So there will be a pseudo force like this, Fp. There will be obviously a normal force like this. Okay. There will be also mg like this. Okay, mg will be here. Okay, great. Now, where will friction act? Will it act up or will it act down? To figure that out, think you're going with maximum speed. If you're going with maximum speed, where will the car tend to move? Where will it try to drift? Will it try to fall down or will it try to fly out? You're trying to go with maximum speed. You're turning the car. You are going like this. Where will the car try to slip? Will it try to go down or will it try to go up? Think about it. The car will try to slip. You will slip that way. You're going with maximum speed. You will be slipping. You will try to slip. You will be pushed outwards. That means friction will oppose the tendency and it will act this way. Think about it. Friction will act this way. So this is where the friction will act. Obviously it will be mu into n in case of the maximum condition. F max. Think about it. Centripetal force will not act. Why, Suchi Mama? Where are we? In a rotating frame. So remember, we are in a non-inertial rotating frame. So in a non-inertial rotating frame, no centripetal force, only centrifugal force. Got it, my warriors? Very, very important. Get the feel. Just imagine you are driving a car and you turn like this. You will be thrown outwards. Friction will try to pull you here. That's what has happened over here, guys. Okay, is that clear? Very good, very good. Now, I think we need to split up some forces. Let's try to do that. I think mg is down. I'll try to split mg into two components. One component like this, one component like this. If this is theta, obviously this angle is theta. Okay, so this will be mg cos theta and this will be mg sin theta. Mg cos, mg sin, standard things which we have been doing. I think I need to split pseudo force also. Okay, you can see pseudo force I have to split like this and like this. You can see that. Oh, by the way, this is angle theta, correct? This is angle theta. So if this is pseudo force, this will be Fp cos theta and this would be Fp sin theta, of course. That's it. These are the components of all the forces. You can now forget about that mg force and that pseudo force because I have already split it. Now let's try to do this question. Okay, in the perpendicular to the plane, let's check what are the forces perpendicular to the plane. Come on, my warriors. What are the forces perpendicular to the plane? I think there is normal and these two bunch of forces are acting this way. Friction is not acting perpendicular to the plane. So can I say normal is balanced by Fp sin and mg cos. Fp sin theta plus mg cos theta. Great. But what is Fp? I know what is Fp. Fp is nothing but m v square divided by r into sin theta plus mg cos theta. Okay, fair enough. I'll just keep it like this. Now let's see parallel to the plane. What are the forces parallel to the plane, guys? Along this plane, I think there is this friction, there is mg sin and there is Fp cos. Only three forces. These two down and that force up. This force and these two forces will cancel each other because you are in the rotating frame. That car will be at rest. Okay, because it is at rest. So So there will be no net force. Okay, that's why I'm balancing these forces. I hope this is clear, because we started our discussion from non-inertial rotating frame. Great. Now what you need to do, just see what are the forces down. The forces down are friction, and there is also mg sine theta. But remember, friction is nothing but mu into n is equal to, what is that, fp cos theta. I think I can substitute the value of normal from here over here. Let's just do that. So see what I'm trying to do, the value of normal from here, I'm just trying to substitute it in this equation and see what do we get. So mu into, okay, this whole thing, that means mv square by r plus, sorry, that's sine theta plus mu into mg cos theta plus this whole thing mg sine theta is equal to fp. What is fp? mv square by r. So mv square by r into cos theta. Let's see what and all gets cancelled. M gets cancelled. Okay, now let's bring similar terms together, like this term and this term together, and this term and this term together. Let's see what happens next. Okay, let's see this, guys. Okay, observe carefully, don't lose focus. I'm bringing these two terms together and these two terms separately. So first let's talk about these two terms. I think G is common, so G is common, and I have mu cos theta, okay, plus sine theta, great, is equal to, here remember m had got cancelled. Oops, I think I didn't cancel it here, m got cancelled. Okay, so v square by r is common, so v square by r, I don't need this anymore, and I have cos theta over here, and from that side I brought mu sine theta, so minus mu sine theta. Cool, great. Let's go ahead. Suchi, you have to love mathematics. You cannot say I don't love mathematics, especially if you are preparing for engineering. Try to solve it. Trust me, you will have fun. Get the fun out of it. Try to see, whenever you see an equation, I want to solve it. I want to know what's the solution. Whenever you want to look for the answer, and when you look for solutions, you will start developing interest in mathematics. Maths is fun, bachalo. Okay, let's do this. I think I want V, so bring this bracket below. So therefore, G into mu cos theta plus sine theta, the whole thing divided by cos theta minus mu sine theta is equal to v square by r. But I don't want v square by r, I just want v, so I'll bring that r over here. So v square will be rg, and I have mu cos theta plus sine theta divided by cos theta minus mu sine theta. Now there is one last step which I will do. And what is that step? I will take the numerator and divide it by cos theta, and because I did that, I will do the same thing with denominator also. What is the advantage of that? You will see. Look at this. So I will have v square is equal to rg, mu cos theta by cos theta is just mu. Okay. Sine by cos, that's tan. Okay, interesting. And cos by cos, that's 1. Minus mu sine by cos, that's tan theta. This looks decent equation. So finally, I think I have got my expression. So V is root of Rg, okay, mu plus tan theta upon 1 minus mu tan theta. That's my final answer, whatever I wanted. And that's it. This is my final answer. Done, done. So this is something which you should again remember, by the way. Okay, great. Wow, very good, Prince. Good, you watched Gravity for revision of gravity. No problem. Good, you did that. So guys, those of you who were very much interested in maths, probably till 9th and 10th, suddenly I know the maths is too much for you guys in 11th and 12th, and especially it is involved in physics also, and calculations are there in chemistry, especially in physical. But that's the way it is, because engineering is all about maths. So if you thought you will get rid of maths very soon, no, that's not going to happen. You have to love maths. And see, what is maths? Maths is a tool which enables us to calculate different stuff without actually having to experiment. See, if maths was not there, I have to actually take a car, okay, and I have to actually ride it and try it out at different speeds. Oh, ride it at 50 kilometers per hour. Oh, ride it at 51, 52, 53. Oh, you slipped. Oh, you died. Okay, he died at 54 kilometers per hour. So the maximum speed is 53 kilometers per hour. So you have to sacrifice a life. So if you don't want to sacrifice a life, you need to know physics and maths. So physics tells me, okay, you have to know about the laws, you need to know about the free body diagram and all of that. So it helps me formulate those equations. What does maths tell me? Maths tells me, okay, how to solve them. So solving that, I'll be able to get the value, and this will obviously avoid that sacrifice of life. I hope that makes sense. Okay, so Kalani, what has happened is this car which was moving at maximum speed will experience pseudo force, normal, mg and friction. Why friction this way? Because it tries to fly out. I have just split mg into two components, pseudo force into two components. Along this line, I have balanced normal and these two forces. Along this line, I have balanced this component and these two forces. That's all I have done, and I have just eliminated the unknown, which is normal, by substituting. Rest all is just solving till you get the velocity. That's it. Okay, so yeah, so Sajay is saying, sir, I get scared whenever I look at variables. It happens with many people. I'll tell you why that fear is there for variables. Because when you have values, you have that, confidence that, okay, this is a number, I know how to play with numbers, but variables do not have values. And the moment they don't have values, you do not know how it is going to work out. You do not know whether it is more, whether it is large. You don't have that feeling. So the best way to love variables is graphs. Trust me on that, is graphs. So try to play with equations, alphabets, like some function, x cube minus 7x. How does it look like? Play with variables. See when it becomes more, see when it becomes less, see how the graph looks like. That's when you will start liking variables and you will feel little bit confident. Because right now you don't have that feeling of how these numbers play out, especially when there is no value associated with it, but there are some alphabets like A, B, C, X, Y, Z and all of that. So that's all you need to do, guys. Okay, this is the answer and this is the homework question. This is the first one. This is based on, unbanked road. So everything is given. Figure out what is the the smallest radius if he's traveling with a speed of 36 kilometers per hour. And the second question is, there is a banked road and this is the radius, the angle is also given. What is the maximum speed? We just solved a question, try to do this. And if you guys want to study under me, so there is a link, I'll just show it to you over here. So if you go to our channel and if you're watching our video right now, all you need to do is go down over here and you will see that there is a JEE course for 2 years. There is also a link for the CBSE batch. There is also a link for the JEE batch. So the JEE batch involves complete studies of 11th and 12th standard. Also there are my micro courses, and also the long-term batch is in English. There is also an option for you to study in Hindi. See guys, if you're not happy with your coaching, it's now the best time, at least it's not so late. You can switch over to Vedantu, because next year it will become late again. Because I don't want you to repent again next year. Although we will be there on YouTube and we will cover all the chapters, but the advantage of joining a long-term batch is you guys will get the complete course, topic specific short notes, revision along with other courses like KVPY. You will not only get the recordings of all the live classes itself, the notes, assignments, because you lack that practice, so you need somebody to give those assignments which you can solve again and again. It will self-evaluate, it will give you a report card, and the tests, because on YouTube unfortunately I cannot conduct tests. If I could, I would have done that. Plus the notes and the booklets, and also you have some doubts, you want somebody to solve them, so you can go for the classic version, else you can go for the light. Most students go for the classic version, and some students who need mentorship, they go for the plus. You can see the total 2-year cost is 61,000 roughly, but per month the cost is roughly 3,300 to 3,600 rupees. So there is an EMI option. And if you buy the complete course, you don't have to pay the complete amount. You can see that over here there is a zero interest EMI out here. Okay, so you don't have to pay the complete amount, and you can opt different banks, whichever option you want, 6 months, 9 months, 12 months. You can see if you opt for 18 months, 3,375. That's very cheap. So you can do that, up to you. Okay, so I'll be looking forward to see you guys in the pro subscription as well. And okay, so I hope you guys had a great time. And well, अच्छा Sunday ला test आहे, कोई बात नहीं. All the best Kalyani, and take care. Shreyas Kapri, hello बच्चा. Bye Prince. So Prince, you will find my micro courses very easily. I'll tell you what, if you want to join my batch, I mean, just on YouTube, just search for Shreyas Sir Pro Subscription. I've given how to find my batches or my courses very easily. So watch that video, search for Shreyas Sir Pro Subscription on YouTube. You will be able to see that video, and which I have shown. This is how you should type, and this is how you should enroll into my batch. Just watch that. Okay, take care, Suresh Kumar. Bye Ishpreet, and do post the answers in the comment section, and let's see who posted really fast, and we'll again read out the names of all the students who posted the answer in the comment box in the next class. Till then, have a great weekend and happy Navratri to all of you. Enjoy. Happy Dashera will be probably later on, but have a great week, guys. It's Navratri, it's festival time. Spend time with your family and have fun. This was your Captain Shreyas. Hasta la vista.